Currently developed processors are electronic integrated circuits. We hear news about quantum computers and processors, but until now they have not been in mass production. The processor controls other elements of the computer. Its main ability is to execute instructions with form programs. While we will go into the details of the instruction set, we will see that some of the instructions perform calculations or process data, while others do not. This suggests that the processor comprises two main units. One of them is responsible for instruction execution, while the second performs data processing. The first one is called the control unit or instruction processor. The second one is named the execution unit or data processor. They are connected to internal addresses, data and control buses, and cooperate with the use of additional internal signals. Let's look at the details of the control unit first. The function of the control unit, also known as the instruction processor, is to fetch, decode and execute instructions. It also generates external signals and internal signals to the execution unit if the instruction being executed requires it. The control unit is a synchronous and sequential circuit. Synchronous means it is changed state synchronously with the clock signal. Sequential means that the next state depends on the input state and the current internal state. As inputs, we can consider not only physical signals from other units of the computer, but also the code of the instruction. To ensure that the computer behaves the same every time it is powered on, the execution unit is set to the known state in the beginning of operation by the reset signal. The typical control unit contains some essential elements: instruction register, shortly IR, instruction decoder, program counter, shortly PC or instruction pointer IP, stack pointer, shortly SP, bus interface unit, and interrupt controller. The control unit executes instructions in a few steps, which look as follows. The control unit retrieves the address of the instruction to be executed from a special register known as the instruction pointer or instruction counter. It sends the address to the memory via the address bus. It also generates signals on the control bus to synchronize memory with the processor. Then the processor fetches the instruction code from the address provided to memory using a data bus. After fetching the instruction code, the instruction pointer is modified to point to the next instruction in a program. The processor stores the instruction code in the instruction register and, based on the bit pattern, interprets what to do next. And if the instruction requires the execution unit operation, the control unit generates signals to control it. The cooperation with the execution unit, it can also need data, read from or write data to the memory. The control unit operates according to the clock signal generator cycles known as main clock cycles. With every clock cycle, some internal operations are performed. One such operation is reading or writing the memory, which sometimes requires more than a single clock cycle. Single memory access is known as a machine cycle. As instruction execution sometimes requires more than one memory access and other actions, the execution of the whole instruction is named an instruction cycle. Summarizing, one instruction execution requires one instruction cycle and several machine cycles, each corresponds of a few main clock cycles. Modern advanced processors are designed in such a way that they are able to execute a single instruction, sometimes even more than one, every single clock cycle. This requires a more complex design of a control unit. Many execution units and other advanced techniques, which make it possible to process more than one instruction at a time. The control unit also accepts impulse signals from peripherals, enabling interrupts and direct memory access mechanisms. For proper return from the interrupt subroutine, the control unit uses a special register called the stack pointer. Interrupts and direct memory access mechanism will be explained in detail in future chapters. An execution unit, also known as a data processor, executes instructions which perform data calculations and manipulations. Typically, it is composed of a few essential elements: arithmetic logic unit, set of registers, flag register, temporal register. The arithmetic logic unit is the element that performs logical and arithmetical calculations. It uses data coming from registers or from memory. Data coming from memory for arithmetic and logic instructions is stored in the temporal register. The result of the calculation is stored back in the register or memory. In some legacy CISC processors, the only possible place for storing the result is the accumulator. Besides the result, the arithmetic logic unit also returns some additional information about the calculations. It modifies bits in the flag register, which comprises flags that are modified according to the result from arithmetic and logical operations. For example, if the result of the addition operation is too large to be stored in the resulting argument, the carry flag is set to indicate such a situation. Typically, the flag registers includes carry flag, set in a case a carry or borrow occurs, sign flag indicating whether the result is negative, zero flag, set in case the result is zero, auxiliary carry flag used in BCD operations, parity flag, which indicates whether the result has an even number of ones. The flags are used as conditions for decision-making instructions, like an if statement in some high-level languages. The flag register can also implement several control flags to enable or disable processor functionalities. An example of such a flag is the interrupt enable flag or the 8086 microprocessors. Registers and memory elements which are placed logically and physically very close to the arithmetical logic unit. It makes them the fastest memory in the whole computer. They are sometimes called scratch registers, and the set of registers is called the register file. The extensive use of registers in calculation makes a program much faster than one that performs operation on the data placed in memory.